Hello friends, welcome to our channel Google Galaxy. Today we are going to discuss about the haloalkanes and haloarenes. Before starting the lecture, I would like to request you to please subscribe this channel so that we'll get emphasize about providing you more educational video. Okay, we are start about the haloalkanes and haloarenes. Most of the people ask about me that what is the purpose behind that we are about to study haloalkanes and haloarenes. I'll say basically there are number of medicines, a stream named pharmacy. The student who adopted the stream pharmacy need to invent a particular medicine which is called as antibiotic, which is used to treatment for the various diseases. For example, in this lecture we are going to talk about the group number 17, group 17 of periodic table, that is called halogen group. That halogen group, there are number of elements over there. Few of them is fluorine, chlorine, bromine, iodine. We are here to discuss about these elements attached with the alkanes. When we say these elements are attached with these alkanes, we call it as haloalkanes. When these halogen group elements are attached with the benzene like group, it is called as haloarenes. Okay? I'll say sorry for you because there are few mistakes will be in the lecture. The reason behind is the English is not one of my first language. Okay, so kindly ignore that. Here we are talking about the when we say halogens are attached with this benzene group, maybe fluorine, maybe chlorine, bromine or iodine, we call it as haloarenes. There is another name for haloarenes, that is aryl halide. Aryl halide. Wherever you see aryl halide or haloarenes, don't get confused. You need not to confuse. It means both are having the same meaning. The reason behind that we are studying this lecture is that there are number of applications in daily to life. We call it as day to life. One of these medicines, we know that chlorine. There are two types of chlorine which are available naturally or we can synthesize in the laboratory. When we talk about the chlorine available naturally, we use for making the antibiotic name chlora, phenicoil. This medicine name called chlorophenicoil is used for treatment for the soil microorganisms, and this medicine is very effective for the treatment of typhoid fever. We also know that our body produces iodine, which contain the hormone called thyroxine. Most of the people having the problem with the goiter. Goiter is basically a throat disease, okay, which may cause many problems for many people. So for this treatment for goiter, we need a particular medicine made with the help of haloalkanes and haloarenes, having the element name chlorine, having the element name, and that medicine is called chlorophenicoil. The another medicine is made with the help of the chlorine. We called it as synthetic halogen because we made it in the laboratory. This synthetic chlorine, I called it as synthetic halogen. Halogen automatic means group number 17. It may be fluorine, it may be chlorine, bromine, iodine, depends upon the, we can say, potency. Okay, we are having the particular name potency in the medicine field. That means we are having the hardness of medicine. Okay, if we are having the low potency, it means it will not having that much effect which is having the higher potency. Clear? So we can say synthetic halogens are used for the surgery, during the surgery, and also having the example of synthetic halogen, we are having the chloroquine. Have you ever heard about this medicine? I have heard. This medicine is called chloroquine, is made in the laboratory. This is, we called it as synthetic halogen. This chloroquine is used for treatment of malaria. All these kinds of medicines are made in the laboratory by the pharmacist, ठीक है, who study the particular field in the pharmacy. ठीक है, they all need a particular type of reactions. They are having chart in the laboratory. They know which chemical will have to react with the which chemical, and we will possible to make treatment over a particular disease. ठीक है, we are having the number of reactions in this whole chapter. We have to understand that reactions and learn it properly, so that we will get success about the haloalkanes and haloarenes. Okay, let's start with about the haloalkanes and haloarenes. This is the basic introduction, that why we are going to study about this chapter. And during the lecture, we come to across with the number of terms. Few terms we are going to discuss that everyone must know. If someone write this kind of formula, X for halogen, you will name it as mono haloalkanes. Mono, why so? Mono for, I will write it as mono haloalkanes. When we say mono means one halogen. Halo matlab, halo means we are talking about the halogen. If someone called is alkanes for C2H5, one must know that during the while writing this kind of formula, we need something like this. This is called as, we are called as alkyl group, and another attached with the chlorine group. If I'll write, we call it as mono haloalkanes. If I will write it as we called it as one halogen group over here, one halogen group over here. We called it as di for two, di haloalkanes. If someone write it like this, don't get confused. We called it as tri haloalkanes. Why will write over 2n plus 1? The reason behind is one of the hydrogen is replaced by the halogen group. If I will write it as CH4, one of the most preferable element called halogen, when interact with this methane, it will replace one of the hydrogen of this group and will get an output like this. One of the hydrogen get removed. So we called it as chloromethane. Otherwise it is called as methane. As soon as the halogen came near to it, made reaction with it, we called it as chloromethane. Similarly, we called it as chloroethane. We called it as dichloroethane. Clear? So this is whole about, there are number of things while doing reaction of this chapter we must have to know about this. Okay, one of things, if someone called you 1 degree means, that is, we are having the carbon. 1 degree means there are only a single alkyl group attached to this carbon atom. This is carbon and halogen. These are hydrogen. Okay, we call it as in alkyl halide. alkyl halide, the halogen atom is bonded with the alkyl group. They form homologous series represented by CnH2n+1 bonded with the chlorine. They are further classified into 1 degree, 2 degree, 3 degree. When we talk about the 1 degree, it means that it is also called primary. It means that a carbon is attached with one of the alkyl group and other two hydrogen group, and halogen always be there. When we talk about the 2 degree, it means that the carbon is attached with the two alkyl group, maybe same, maybe or different. One of the halogen must be there and one is hydrogen is always there. It means that as soon as we are raising the degree of this 1 degree, 2 degree, 3 degree, we are getting more and more alkyl group. When we talk about the 3 degree, it means that 3 alkyl groups are attached to a single carbon atom, maybe same, maybe different. So we call it as tertiary, we call it as secondary, we call it as primary. Clear? Okay. Next we are having the nature of carbon and halogen bond. Nature of carbon and halogen bond. We know that the halogen atoms are having more electronegative than carbon. What is electronegativity? Electronegativity is power to attract the electrons. What is electronegativity? We will say power to attract electrons. Power to attract electrons. Halogen atoms are more. Halogen means group number 17, chlorine, fluorine, bromine, iodine. These elements are known as group number 17 of periodic table. We call these elements combined as halogen group. Halogen atoms are more electronegative than carbon. The carbon and the halogen of this alkyl halide is polarized. Why so? Because of higher electronegativity. Since the halogen is having higher electronegativity, it will attract the whole common electron density towards itself. When carbon and the halogen both bonded together, they are having common nucleus and they share electrons with each other. Because of higher electronegativity of this halogen, it will attract almost more than the half. More will be the electronegativity, more will be the power to attract electrons. If I'll say fluorine is having more capacity to attract the higher electron density towards itself, I'll say chlorine is having power to attract electrons of carbon but less than fluorine. So we'll say each element is having its own capacity to attract the electrons towards itself when they are attached with the carbon atom. When the halogen is joined with the carbon atom, it will attract the electron density towards itself. Hence, they bear partially positive charge on the carbon atom and the partially negative charge on the halogen. More power to attract the electrons, more will be the negative charge on halogen, more will be the positive charge on carbon. Since the size of halogen increases as we move down to group, in a periodic table, fluorine is having the smallest and the iodine is having the largest size. I'll say largest size, smallest size. Since the size is keep on increasing as we move down to group, therefore the bond length also increases. Bond length also increases. It means that chlorine, carbon, and when the carbon and the fluorine bonded together, they are having the less bond length than carbon and iodine. So depending upon their bond length, they are having different bond enthalpy. What is called bond enthalpy? What is bond enthalpy? It means that when we break the bond between these two, how much heat we required to break that bond. This is whole about the electronegative. If I will say this is one of the compound meth-eth, so we call it as ethyl. Why ethyl? CnH2n plus 1, and the halogen is attached to this element. I'll say this ethyl is we call it as alkyl group. This halogen is attached to it. As soon as higher electronegative element is attached to this alkyl group, the electron density starts shifting towards itself, because it starts towards the halogen. Why so? Because of higher electronegativity. Hence they get polarized, partially polarized depending upon the type of halogen. If I'll say fluorine, more will be the negative charge on halogen, so we called it as halogen group get the negative charge and the alkyl group get positive charge. As we move further away from the halogen, we are talking about the hybridization. This is topic we need. For the hybridization, we need to calculate the number of sigma bond. Okay. For example, if I'll say we are having 2 carbon atoms and the hydrogens are attached to this, we call it as number of sigma bond is, first one is always sigma, second one is always pi. If I'll just write carbon and oxygen, it means that first one is always sigma, second one is always pi. Sigma, pi. So we need to count the number of sigma bond. Here for this carbon atom, this is first carbon atom, second carbon atom. For this carbon atom we are having the 1, 2, 3, 4, 4, that is sp, spp, we call it as sp3. For this carbon atom we are having the hybrid sp3. For this carbon atom we are also having the sp3 hybridization. When we talk about the CH3X, that is halogen is attached to the alkyl group, that is haloalkanes. So number of sigma bond is 1, 2, 3, 4. So we call it as sp3. So we know that for every haloalkane the hybridization is always sp3, and for haloarenes we are having chlorine. This is alternating double bond. So when we talk about this carbon atom, how many sigma bonds are there? We called it as sp2. How many? 1, 2, 3. This is pi bond. We need not to count. We have to just count the number of sigma bond. So for haloarenes the hybridization is always sp2, and for haloalkanes we are always having the sp3 hybridization. Clear? If you like this video, please subscribe to our channel.